Okay, so in this last example for our lesson, we're going to learn about trigonometric inverses. So we know what our trig functions are, sine, cosine, tangent. We can use trigonometric inverses to find angle measures. Your trigonometric inverses look like this. Here's your inverse sine. Sine it looks like an exponent of -1. It's not sine raised to a power of -1. That's just our symbol for inverse sine. We have our inverse cosine and our inverse tangent function. All right, so part A, what are the measure of angle A and angle B? So if we look at the picture, we see that we have two sides of a right triangle. They're not asking us to find the third side. They're actually asking us to find angle A first and then find angle B second. Well, we can use trigonometry to find missing angles. We're going to set up our trig equation like we did in the last video. So first, angle A is right here. We know the hypotenuse and we know the adjacent side for angle A. So which trig function uses the adjacent and the hypotenuse? That is your cosine function. So our trig equation looks like cosine of angle A, which we don't know, so we'll just write angle A, is equal to the adjacent side over the hypotenuse. So how do we take this equation and solve for A? We can't divide by cosine because it's not cosine times A, it's cosine of angle A. So what we do is we bring in our inverse cosine function. So angle A is equal to the inverse cosine of that trig ratio 1/4. So then you might say, okay, well, great. What do we do with that? Well, guess what? You have an inverse cosine button on your calculator. Well, you probably don't actually have this button, but you have a cosine button. In most calculators, if you hit second cosine, that's how you'll get your inverse cosine function. So angle A is equal to, if you hit second inverse of 1/4, you will get 75.5 degrees, just rounding to the nearest tenth. All right, now they want us to find angle B. So I'm going to erase how I labeled the triangle, because I'm going to look at angle B now. The opposite side is 1. And the hypotenuse is 4. So we're going to use a trig function that uses the opposite and hypotenuse sides, and that is your sine function. So the sine of angle B is equal to the opposite side over the hypotenuse. Now, anytime that I need an angle measure, I use the inverse function. So angle B is equal to the inverse sine of 1/4. Then we grab our calculators and we type in angle B is about equal to 14.5 degrees with some rounding. And I mean, that kind of makes sense. A and B will add up to 90, and we just found A and B and they do add up to 90. So just a good little check that we are doing correct math on this. All right, we're just going to practice one more time just to get the hang of it. What are the measures of angles P and Q? So if we're looking at angle P, here's angle P. I'm going to label my triangle in reference to angle P. So we have our opposite side over here. We don't know the hypotenuse, but this 3 is our adjacent. So which trig function uses the opposite and the adjacent? And that is our tangent function. So the tangent of angle P is equal to the opposite 2 over the adjacent 3. Now, when you need to find an angle measure, you use your inverse function. So angle P is equal to the inverse tangent of 2/3. And when we type that into our calculators, we get about 33.7 degrees. All right, I'm going to come up to the picture, erase my labels, because now we need to find angle Q. So my labels might change. Now the opposite side is 3. We still don't know the hypotenuse, but the adjacent side is 2. Well, which trig function uses opposite and adjacent? Oh, that's our tangent function again. So tangent of angle Q is equal to the opposite side 3 over the adjacent side 2. Because we're trying to find an angle, we use our inverse tangent function. So our angle Q is equal to the inverse tangent of 3/2. We grab our calculators and we type that in, rounding to the nearest tenth. That is a 56.3 degree angle.